Hello everybody, my name is Alberto and I am a game developer. Finally, I got time to continue with this series of videos in code design with Unity. In the last video, we saw the implementation of our game entry point, how we can feed it with the different callbacks from Unity, and how we create our core C# object, which is going to be a container for all the systems that play a role in the game logic of our game. Today, we will see the implementation of the update system and one example system which deals with Unity behaviors, and then we can see the connection from this system to our update system. The creation of our update system is done in the initialization of our game instance and is directly added to the systems group. Let's take a look to the implementation of our update system. We're going to mark this system as public because this is going to be accessed by most of the other systems. We want to be able to update at different times. If we look at this enum, we have three different possibilities, which correspond to the different update callbacks of Unity. But of course, you could add here different update times, for example, prefix and postfix, if you are interested in performing certain actions before the fix update or after the fix update. This is up to you how complex, and it basically depends on what your game requests. In the constructor, we are going to create all the different game updaters for the different update times. The implementation of this system is straightforward. We just only need to make sure that we dispose all these updaters in the destroy method. For adding updatables, we just need to pass update time where we are going to allocate this updatable, a hash which will be needed to identify it, and finally the action we want to invoke, which comes with a float because we want to pass the delta time in which we are performing this update. The rest is quite straightforward, removing an updatable using the hash and the time, checking if that updatable exists, and finally feeding the different updaters with the different update times. Here is where we, again, if we have a prefix or postfix, we could place them before and after this update. So this is up to you and how complex or elaborated you want to have this system. But as you can see here, it's a pretty simple and straightforward system. Let's take a look to the implementation of the game updater. The most important thing to note is that we want to allocate all these updatables in a unidimensional array. This makes the process of updating this iteration much faster than if we were using other collections like a list. In the constructor, we are going to initialize this array with a max capacity. This is not going to be dynamically changed during runtime, and this will make the process much more efficient. So this value here is really important, and in the game, probably you want to have it per levels, or it just, of course, depends on the type of game you're making. The other important part of the implementation is the dictionary over here. This keeps the relation between the hash of the updatable and the position in the array. When we are adding our updatable, we check if it exists over there. So we are already performing the hash updatable operation, which makes it quite safe. So you could be adding twice, that there is no problem. It's going to be only once in our updatables array. If it is not in the indexes, we can add it to our array, and then we just add it to the updatable indexes. Here we increase the current index. This current index is the other relevant part. The current index defines the length of the updatables. Well, it's not the length is defined by the max capacity, but is our actual length, where is our last element that we are updating. When we are removing updatables, this is very important because what we are going to do is basically swap the last element, which is defined by the current index, with the one that we are removing. So after performing this operation and decreasing one the index, then we can basically say that this element has been removed, even though it is still in the array, but it is outside of our bounds of our current index. And we don't have to perform any operation, reallocate, create another temporary array. This is no needed. We are just swapping one element with another. The only performance cost is here is that we have to access this dictionary every time this happens. So this is something to take into account and check if this is a problem or not. If we are removing and adding adaptables lots of times, then this can become a problem. But the whole point of this system is to be fed by other systems. So you have a system which will have a bunch of mono behaviors, as we will see now, and the system will just subscribe here, and that this system will be responsible for updating all these mono behaviors. It's not that every mono behavior is going to subscribe to this updater. So let's continue and we will see this part, and we will see that this cost of accessing an element in the dictionary probably should not be a problem if we use this update system in the right way. Finally, let's make sure we clean up on this posing. Let's now then take a look to an example system. I've made this system over here. If we check the system, what we can see is that first we will need a reference to our update system. This is one of the core things of this pattern or of this design. We are going to perform what is called injection dependency. So every system that needs other systems will be getting this system via the constructor. In this way, we are also defining the order in which we initialize or create these different systems. So here you can see that we are passing the update system, and we are also passing all these example behaviors. Well, what are these example behaviors? As I said before, I wanted to show you an example in which we use a system which is connected with a lot of behaviors, mono behaviors, and we want to update these mono behaviors using this system. Again, we are going to store all these mono behaviors in a unidimensional array. You will see that I use this pattern a lot. This is the most efficient way of iterating when you have to perform this iteration every frame. This is the best way you can have it, and you can always have an index which defines the last element that exists in this array. Well, it's not that exists, but it's the one you want to update, the last one. So we are getting these examples from the game instance. Let's take a look here. I'm performing this operation. This is an expensive operation which happens only once when we are initializing. Even though there are better ways of doing this, we could cache all these elements in the editor and then have just the reference already here. That, of course, will be needed when the game grows, and if you really have a lot of different mono behaviors, this can be annoying on the initialization, the waiting time. So that's always up to you. I'm performing it simple now here, but again, there are always tricks to do. So here we are going to get a unique hash for our system. Then we are going to start adding all our examples. We initialize the array with the maximum length, and here we want to perform some operations. So for each example, we want to subscribe to enable and disable. Why? Because we are dealing with mono behaviors, right? We want to only update them when they are enabled. So if we take a look here, there are again several ways of implementing this. The approach I followed here is to part from a base behavior, which is going to be a bit our core behavior. And this behavior here has just this simple implementation. Well, has like a action for when it is enabled and disabled, and just have a reference to the instance it belongs to. This is fire in the onEnable and onDisable from the mono behavior. And we can see here that the instance is just a reference to itself. And here we have just an example of what would happen with the frame update. The other important part is the array index. Let's take a look to what is this now. Well, here when we've created or added all these examples, and when the enable actually happens, let's take a look here. What we do is to, well, place this example in the last position of the array. It's now the last one. We tell, hey, you are in this array index, and this is why we need that. We need this reference, and we increase the last index 1. So this is going to be our last element 1 plus. And then here I have a debug method that logging something we will see now when we go to the editor and test over this. If we disable one of these example behaviors, what we are doing is exactly the same that with updater. We are going to swap the last element with the one we are removing. And here make sure that when you set the last element as this element, we update also the array index. Now is this index the one of the last element, and we decrease 1 our last array. So this is a very simple way. Then every time the frame update will happen, we will be updating all these MonoBehavior, all these examples, one by one in our unidimensional array over here. And here you can see that I'm not adding to the update system and removing to the update system each MonoBehavior. I'm just adding this frame update method, which is from this system, and I'm adding it only once when we enable the system, and when we disable the system, we are going to remove it. Enable and disable system is something that is up to you when to do it. In this case, you probably will want to keep it enabled the whole time, but some cases, some systems, you want to be able to enable and disable them. Okay, let's just take a look in the editor if this actually works. In this pretty empty scene, I have here a bunch of examples, which has the example behavior component, and we have the game entry point over here. We don't have anything else. We don't need anything else. If you remember, we have two debugging law, one when this is enabled and one when this is disabled. Let's then take a look what happens when we start the game. Well, here we get a lot of different logging. All of these were enabled, so this means that all of them in the example system, I think you can see it, yeah, they have been added to the array. And as you can see, the order, example 1274, is not straightforward. So that is something interesting to take into account. The order you place the child here has nothing to do with the order they will start enabling, as you can see over here. But we know from this debugging which one is in which position. And in our case, they start enabling and they all get a different position, up to 20 positions in the array. So let's, for instance, get the example number 9. It is in position 7. And let's see what happens if we disable it. Well, the example 9 was in array 7 and now it's disabled. Now the example 14 is at 7. Well, here we have the 14. That was the last one. Now it is placed there, so it is in number 7. So we swap them, and then we keep updating without any error because we are not outside any bounds of the array. And this works as expected. If we enable, then now our example 9 is enabled and placed in the array number 20. Well, that was it for today. I hope you can see with this very simple example how powerful can be having this control. You don't have to care anymore. You can just disable and enable these MonoBehaviours, and the systems behind them will take care that things happen in the right way. The moment you want to stop everything working, you just disable the system, or you just enable the system to make it work. So it's all up to you. You have the control, and this is the whole point of this design, having the control over there. And the other part is the injection dependency. You are also forced to follow certain orders, certain patterns to perform the things, which can be more costful in sense of code, a bit more annoying, but it makes it less prone to having bugs and much more easy to debug also. So thanks a lot for joining me, and I hope to see you next time. For the next time, I need to check what's the next thing to work on, but probably we will continue taking a look to the different systems we can make and how we are distributing them in our game instance.